Welcome to The Explainer. Today, we're diving headfirst into one of the biggest, most mind-bending paradoxes in modern physics, the measure problem. It's an idea so tricky, it kind of threatens to make the entire concept of the multiverse, well, scientifically meaningless.
And this question right here, it really cuts to the chase. I mean, the whole idea of a multiverse is just so cool, but like it says, if we can't actually use it to make real, solid predictions, is it real science? Or is it just a fascinating story we tell ourselves?
So to really get our heads around the measure problem, we have to start with the incredible theory that cooked it up in the first place, eternal inflation. This is the idea that tries to explain, well, everything.
So picture this. Space itself is like this vast cosmic ocean that's always boiling. And every single bubble that forms and breaks away, that's not just a bubble of air. That's a whole new universe. Each one could have its own laws of physics, its own unique constants, its own destiny. And the craziest part? This process is supposed to go on forever.
Now, you can see why physicists love this idea, right? It gives us a potential solution to what's called the fine-tuning problem. That's the weird observation that the basic numbers of our universe, like the strength of gravity, seem just perfect for life to exist. It's almost suspicious. But with a multiverse, you don't need a miracle. If you have infinite universes, it's pretty much guaranteed that at least one of them, ours, would get the recipe for stars, planets, and us just right.
Okay, but, and this is a big but, this is where that beautiful, elegant picture starts to get really, really messy. The second you bring the word infinity into the mix, our normal rules of math and logic just start to fall apart.
And here we are, this is the bad guy in our story, the measure problem. In science, you have to be able to calculate the odds of something happening. But how in the world are you supposed to calculate odds when your sample size, the number of universes, is literally infinite?
Think about it like this. If I told you to pick a typical number from the set of all integers, which goes on forever, what would you choose? 10? 1,000? A billion? There's no right answer, because there's just no such thing as a typical integer. Well, that exact same problem hits us when we think about the multiverse. If you can't define what a typical universe looks like, you can't make any predictions.
And this isn't just a hypothetical thing. When physicists actually try to create a rule for counting, it gets wild. For instance, if you decide typical means younger universes, the math says observers like us should be pretty common. Great. But if you decide typical means bigger universes, the math predicts that huge, empty, fast-expanding universes should be the norm. You see the problem? Two different ways of counting give you two completely opposite answers. The theory can't tell us what to expect.
And believe me, this isn't just some abstract, nerdy debate for mathematicians. The consequences of the measure problem lead to one of the weirdest, most unsettling ideas in all of science.
Yup, you read that correctly. It's a thought experiment about a lonely, disembodied brain that just randomly pops into existence from the pure chaos of space. For one single moment, it thinks, I exist. Maybe it even has fake memories of a whole life, and then poof, it's gone. A cosmic zombie brain.
And this is the catastrophe. In an infinite, mostly chaotic multiverse, it's actually way, way easier for a random fluctuation to accidentally assemble one simple thing, like a brain, than it is to create an entire, complex, ordered universe with billions of years of evolution leading up to that brain. So the terrifying result is that almost any way you do the math, it predicts that there should be infinitely more Boltzmann brains than observers like us.
This is a massive red flag. I mean, any scientific theory that predicts we are overwhelmingly likely not to exist the way we do, well, that theory has a major, major problem. If the theory says you should be a Boltzmann brain, but you're looking around at a stable, logical world, then the theory is probably wrong.
So as you can imagine, this whole catastrophe has kicked off this huge investigation. Physicists and cosmologists have basically turned into cosmic detectives, and they're all trying to find the one true ruler, the right way to measure things, that can tame infinity and save the multiverse from itself.
And the search is definitely on. People are trying everything. Some are trying to put mathematical fences around infinity to tame it. Others are tweaking the physics of inflation itself. Some are even trying to find clues in the data from our own cosmos. But so far, not a single one of these solutions has been a slam dunk. The mystery is still very much unsolved.
Which brings us all the way back to where we started, with that really big, crucial question. If there's no solution to the measure problem, what is the multiverse theory, really? What is its place in science?
Look, at the end of the day, here's the bedrock of science. A theory has to be falsifiable. That's just a fancy way of saying you have to be able to prove it wrong. If your theory can explain any possible thing you see by just saying, oh, that just happens in one of the other infinite universes, then it doesn't really predict anything. It stops being science and it starts looking a lot more like philosophy.
So we are left hanging, right on the edge of this cosmic mystery. Is the measure problem the nail in the coffin for the multiverse? The thing that sends it to the realm of science fiction? Or is it a clue? A signpost pointing us toward an even deeper, more fundamental theory of reality that we can't even imagine yet? Honestly, that's the question that keeps cosmologists up at night.